Alright, so today I want to talk about motion along a straight line, displacement, time, and average velocity. So in this whole example it's going to involve Superman. Alright, so now as you can see here we have Superman. He's flying above Metropolis in a straight line, and so we have our coordinate system, which is just the x-axis. So the origin of our coordinate system is at 0 meters, and it goes to 13 meters. Okay, so displacement. Well, displacement is the distance a body is from where it started, or from the origin. Now, let's say that Superman's apartment building is somewhere over here, and this right here, at the origin, this is his window. So he flies out his window and he just goes across Metropolis in a straight line. Okay, so now his displacement is from 0 to 11 meters. Right, so now we say that delta x, or the change in x, is equal to x2 minus x1. Okay, so the change in his x position, or the x position of whatever body we're analyzing. So now that's 11 meters x2 minus 0 meters x1, and that's equal to 11 meters. Okay, so his displacement is 11 meters. Now, displacement is different from distance. So distance will be how many meters he covered in total, and the displacement is just concerned with his start and ending locations. So, for example, if from flying out his window, he was just having fun and he just flew around in circles and whatever. So then he ended up at x is equal to 11 meters. Well, his distance could have been hundreds of meters, because in between, who knows what he was doing. He was just, flying around, just, having fun. So he flew hundreds of meters, but he ended up at x is equal to 11 meters. So his distance is hundreds of meters, but his displacement is just 11 meters, as you can see here from the delta x. Okay, so now suppose he flew out his window and he went to x is equal to 11 meters, and he said, oh no, okay, I forgot something at home. Alright, so he flew back, right, and then he stood at home. Alright, so well, what is his displacement then? It's 0. So as you can see, delta x is equal to 0 meters where he started minus 0 meters where he ended, because he went back home, and is equal to 0 meters. So displacement is 0 meters, but his actual distance traveled is 22 meters, because he went out 11 meters and then he went back home 11 meters. So he traveled 22 meters in distance, but his displacement is 0 because he ended where he started. So the distance between his ending and starting locations is 0 meters, because they're the same location. Okay, so now we talk a little bit about time. So we say the change in time, delta t, is equal to t2 minus t1. Okay, so now that just concerns how long he was traveling for, basically. Okay, so let's say that in the traveling from 0 meters to 11 meters, it took him 2 seconds. So now t2 is 2 seconds minus t1, 0 seconds, because we're just taking 0 seconds as like the very start of whatever motion he's going to exhibit. So 0 seconds, and that's equal to 2 seconds. So the change in time, or the time elapsed during his motion, is 2 seconds. Okay, easy enough. Now, let me just get rid of this stuff. Okay. Alright, so just move this up. Okay, so now we have the two quantities we need in order to compute the average velocity, the average x velocity. Okay, so the average x velocity, or the component of the velocity, of the average velocity in the x direction, is equal to delta x divided by delta t, or the change in displacement over the change in time. Okay, so in the case of Superman, we have delta x as x2 is equal to 11 meters minus x1, 0 meters, divided by t2. Remember, it took him 2 seconds, so 2 seconds minus 0 seconds. Okay, so now that gives us 11 meters divided by 2 seconds, or 5 meters per second. So that's just telling us that if he keeps this up, it's a constant velocity. So if he keeps this up, then he will travel 5 meters every second. Okay, and notice this is positive, so that just means that he's traveling in the positive x direction. And in most problems, you'll be able to choose what's the positive x direction or positive y, and what is the negative direction. Okay, so basically a negative sign would just mean that he's traveling in the negative x direction as chosen by us at the start of the problem. So if we defined motion to the right as positive, then motion to the left is negative. Okay, so now let's do an example with negative x velocity and negative displacement. Okay, so now you see here Superman is going from, he started at 11 meters and he's going back home. Let's say he was somewhere, fighting a bad guy 11 meters away. He's like, okay, I'm done, I'm going home. Okay, so he flies home in a straight line. Alright, so in this case, delta x is going to be x2, which is x2, which is 0 meters, and minus x1, which is 11 meters, because that's where he started, and that's negative 11 meters. Oh, I'm sorry, this is 5.5 meters. I said 5, okay. Okay, 5.5 meters. Right, okay, so now basically his change in x position is negative, which means that he's going in the direction opposite of what we chose positive movement to be. So he's moving to the left. So that's what the negative means. It's not like, okay, negative, like a lack of something. It's just denoting direction. The positive and negative denote direction. Okay, so now let's say that he takes the same amount of time, right? So 2 seconds. So now what is his average x velocity in this case? Well, it's just delta x over delta t, which is equal to, well, delta x here is negative 11 meters, and delta t is still equal to 2 seconds, as we found out before, and that's equal to negative 5.5 meters per second. Okay, so, well, again, this negative sign just means that he's moving in the negative direction. He's traveling in the negative direction, and he's going 5.5 meters every second. That's how much ground he's covering. So I want to show a graph that would illustrate this a little more. Okay, so this isn't an exact model of this exact situation with Superman, but as you can see, it's a graph with a coordinate system of x displacement in meters over t time in seconds. So in this model, it shows that it starts from a time t is equal to 0 to t is equal to 10, and from x is equal to 2 to x is equal to 11. So now let's say that Superman traveled for 10 seconds here, and then he went from, we just care about his 2 meter mark, from 2 meters to 11 meters. Well, so then this black curve here represents his x displacement over time, and this orange line here, the slope of this orange line shows the average x velocity in this time interval. So we're concerned with, when we compute an average, we're concerned with 2 points, the starting and ending points of the motion. And so just like we had here, 11 meters minus 0 meters, these are 2 endpoints. Okay, so now anything between, if this curve extended far above this coordinate system and this part of the curve extended far before the coordinate system, that wouldn't matter, because we're just concerned with these 2 points corresponding to our problem. So anything between, so this line shows the average change in x on this part, in this part of the curve. So the slope of this line is the average velocity.